The science behind Dyson Spheres. Welcome to our deep dive into the fascinating concept of Dyson Spheres. In this video, we'll explore the origins, theoretical underpinnings, potential construction methods, and implications of this colossal megastructure. The idea of a Dyson sphere captures the imagination, bridging the gap between science fiction and theoretical astrophysics. Let's begin our journey into the science behind Dyson Spheres. Introduction to Dyson Spheres. A Dyson sphere is a hypothetical megastructure originally proposed by the physicist and mathematician Freeman Dyson in 1960. Dyson postulated that as a civilization advances, its energy needs will exponentially increase, ultimately requiring the energy output of an entire star. A Dyson sphere in its simplest form is a structure that encompasses a star to capture a significant portion, if not all, of its power output. Dyson's original concept wasn't necessarily a solid shell, but rather a swarm or collection of solar power satellites orbiting in a dense formation around the star. These satellites would capture solar energy and transmit it back to the inhabited areas of the civilization. The origins of the concept. Freeman Dyson was inspired by the works of science fiction, particularly Olaf Stapledon's novel Star Maker, 1937, which describes advanced civilizations manipulating stars. Dyson's 1960 paper, Search for Artificial Stellar Sources of Infrared Radiation, posited that searching for infrared emissions could be a method to detect such advanced civilizations. Dyson hypothesized that a civilization might create an artificial biosphere to enclose their star, harnessing nearly all its energy output. This biosphere would emit infrared radiation as a result of the captured energy being used and re-radiated, making it detectable from Earth. Theoretical underpinnings. To understand the science behind Dyson spheres, we need to delve into several key concepts. 1. Energy consumption and Kardashev scale. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, categorizes civilizations based on their energy consumption. Type 1, a civilization that harnesses all the energy available on its home planet. Type 2, a civilization that captures all the energy output of its star. Type 3, a civilization that controls energy on the scale of its entire galaxy. A Dyson sphere is associated with a Type 2 civilization. And stellar energy output. The Sun, for example, emits roughly 3.8 times 1026 watts of energy. Capturing even a fraction of this output would provide an astronomical amount of power compared to our current energy consumption. Engineering challenges. Constructing a Dyson sphere presents immense engineering challenges. Material strength. The structure would need materials of extraordinary strength to withstand the immense gravitational forces and heat. Stability and orbit. Maintaining a stable orbit and preventing the satellites from colliding or drifting apart is crucial. Energy transmission. Efficiently transmitting captured energy back to the civilization's habitable areas poses significant technological hurdles. Types of Dyson spheres. Several variations of the Dyson sphere concept have been proposed, each with different structural and technological assumptions. 1. Dyson Swarm. This is the most feasible and commonly imagined variant. It consists of a vast number of solar power satellites in independent orbits around the star. Each satellite captures solar energy and transmits it wirelessly to the civilization. This concept avoids the immense structural challenges of a solid shell. 2. Dyson Bubble. This variation involves satellites positioned at a fixed distance from the star, maintained by light pressure or other propulsion methods. It would be less dense than a swarm but still capture a significant portion of the star's energy. 3. Dyson Shell. The classic but least feasible variant is a solid shell enclosing the star. The structural integrity required for such a shell, as well as the material constraints, make this concept highly speculative. Or Dyson Net. A hypothetical mesh-like structure that captures solar energy while allowing most of the starlight to pass through. This would reduce the material requirements compared to a solid shell. Construction methods. Constructing a Dyson sphere, regardless of the type, would be an undertaking of unprecedented scale and complexity. Here are some theoretical construction methods and the technologies that might be employed. 1. Self-replicating robots. One proposed method involves using von Neumann probes, self-replicating robots that could mine materials and construct components of the Dyson Sphere. These robots would replicate and spread throughout the solar system, exponentially increasing the construction rate. 2. Material resources. The materials required for constructing a Dyson Sphere would likely come from the disassembly of planets and asteroids. For instance, Mercury has been suggested as a prime candidate due to its proximity to the Sun and abundant metallic resources. 3. Nanotechnology. Advances in nanotechnology could enable the creation of extremely strong, lightweight materials necessary for the structure. Carbon nanotubes and graphene are often cited as potential building materials due to their high strength-to-weight ratios. 4. Space-based manufacturing. Large-scale space-based manufacturing facilities would be required to process materials and assemble the components of the Dyson Sphere. These facilities would operate in space to avoid the high energy costs of launching materials from Earth. 5. Energy transmission. Transmitting the captured energy back to the civilization's habitable areas would likely involve wireless power transmission technologies such as microwave beams or laser systems. These methods would need to be highly efficient to minimize energy loss over vast distances. Implications and challenges. The construction and operation of a Dyson Sphere would have profound implications and present numerous challenges. 1. Technological leap. The development of a Dyson Sphere would represent a monumental leap in technological capability. It would require advances in materials science, robotics, energy transmission, and space engineering. 2. Economic and social impact. The resources and coordination required for such a project would fundamentally reshape the economic and social structures of the civilization. It would likely involve unprecedented levels of international or interplanetary cooperation. 3. Environmental considerations. Disassembling planets for resources would have significant environmental impacts. Ensuring the sustainability and minimizing the ecological footprint of such an undertaking would be crucial. 4. Energy management. Harnessing the energy output of an entire star would provide virtually limitless power. Managing and distributing this energy efficiently would be a key challenge. It could enable new technologies and industries, potentially transforming every aspect of the civilization. 5. Astrobiological implications. The search for extraterrestrial intelligence, SETI, could potentially detect Dyson spheres around distant stars. This would provide evidence of advanced civilizations and fundamentally alter our understanding of our place in the universe. Dyson spheres in science fiction. The concept of Dyson spheres has been popularized in science fiction, which often explores their implications and the civilizations that build them. Some notable examples include Star Trek. In the episode Relics, the crew of the USS Enterprise discovers a Dyson sphere with a habitable interior surface. Larry Niven's Ringworld. Although not a Dyson sphere, Niven's Ringworld features a massive ring structure encircling a star, capturing many of the same ideas. 3. Alistair Reynolds' Revelation space series features various megastructures, including Dyson-like swarms built by advanced civilizations. 4. Isaac Asimov's The Gods Themselves discusses the concept of harnessing stellar energy and the potential consequences. Science fiction serves as a fertile ground for exploring the potential and consequences of Dyson spheres, inspiring both scientific inquiry and the popular imagination. Conclusion. The concept of Dyson spheres stands at the intersection of theoretical physics, engineering, and science fiction. While currently beyond our technological capabilities, the idea encapsulates the drive to explore and harness the universe's vast energy resources. As we continue to advance technologically, the dream of constructing such megastructures may one day move from the realm of speculation to reality. Dyson spheres represent the ultimate expression of energy capture and utilization, embodying the potential for civilizations to transcend planetary limitations and tap directly into the power of the stars. Whether as a scientific concept or a visionary goal, Dyson spheres challenge us to rethink the boundaries of possibility and envision a future where humanity harnesses the full energy of its star. Thank you for joining us on this journey through the science behind Dyson Spheres. If you enjoyed this video, please like, subscribe and share your thoughts in the comments below. What do you think the future holds for humanity and the potential of megastructures like Dyson Spheres? Until next time, keep looking to the stars.